I'm Mihaela Blenda, a program manager on the SQL Server team. In this session, I'm going to cover some of the high availability and disaster recovery solutions we plan for SQL Server 2017 on Linux. As stated since our first public preview release back in November 2016, our goal for SQL Server on Linux is to enable all spectrum of high availability and disaster recovery solutions available on Windows today. CTP1 release included backup restore and shared disk failover clustering, and with CTP 1.3 we released always-on availability groups capabilities in all flavors. Log shipping is being released as well. We are going to focus in this session on always-on availability groups as a mission-critical HADR solution for SQL Server on Linux. So let's go through a series of scenarios that availability groups are enabling in SQL Server 2017. To start with, let's assume you are an organization with an all Linux infrastructure. You are building a mission-critical application, and now with SQL Server being available on the new platform, you are considering using SQL Server on Linux. To enable such scenarios, we are bringing always-on availability groups on Linux. This feature is now available on all Linux distributions SQL Server 2017 supports: Red Hat Enterprise Linux, Ubuntu, and SUSE Linux Enterprise Server. Also, all capabilities that make availability groups a flexible, integrated, and efficient HADR solution are available on Linux as well. We have multi-database failover, transparent failover using floating IP resource, multiple async secondary replicas, manual and automatic failover with no data loss, and read-only secondary replicas. Automatic seeding, database-level health monitoring, and failover trigger, as well as disaster recovery configurations are also available. As you know, on Windows, always-on depends on Windows Server failover clustering for distributed metadata storage, failure detection, and failover orchestration. On Linux, we are enabling availability groups to integrate natively with Linux clustering technologies like Pacemaker. You can add a previously configured availability group as a resource to a Pacemaker cluster, and all the orchestration regarding monitoring, failure detection, and failover is taken care of. We are going to see later in the demo how to configure this high availability setup. Next, let's focus on another scenario. You are a customer that has a SaaS application like a website, which uses a catalog database with a high number of read transactions. Previously, you had to set up a cluster to offload read workloads for the application to readable secondary replicas. Now, you can create a group of replicated databases and leverage the fastest replication technology for SQL Server, and no cluster setup is required. Note, these new capabilities are available for SQL Server running on both Windows and Linux platforms. Also, this is not an HA configuration, as there is no orchestration for automatic monitoring and failover. If you do need HA, make sure you integrate with a cluster technology like Windows Server failover clustering on Windows or Pacemaker on Linux. Lastly, let's consider the example of an ISV with a solution on Windows, and now with SQL Server available on Linux, you want to certify the solution on Linux as well. Or the example of an enterprise moving SQL Server workloads to a Linux infrastructure. But due to business requirements related to availability SLAs, the migration must be live with minimum downtime. Using SQL Server 2017, you can migrate SQL Server workloads cross-platform by setting up a distributed availability group with primary on Windows and secondary on Linux. We do not recommend running in this configuration in a steady state, as there is no cluster manager for cross-platform orchestration, but it is the fastest solution for a cross-platform migration with minimum downtime. Now, let's see a demo on how to create an availability group for high availability configuration on Linux and how to add it as a resource to a Pacemaker cluster. So let's see how we can create an availability group on Linux and how we can add it to a Pacemaker cluster as a resource. We're going to start configuring the availability group using SSMS. So just going to the using availability group wizard, we're going to go to SSMS and create an external cluster type availability group. This value external for the cluster type option specifies that the user's intention is to use the availability group for an HA configuration, and the cluster manager is an external entity. In this case, it will be a pacemaker cluster. So let's go through the setup. We just have to specify the name of the availability group, add a database to it, and this is the primary replica that I'm already connected to. I'm just going to add a secondary replica and making synchronous commit. I already created the endpoints because I'm using certificate authentication. So I already have the endpoints and nothing else is required. And also I'm going to use automatic seeding. Now it's available on Linux as well. And nothing else is required by the setup. And in just a few seconds, I have everything configured. So going to the Object Explorer, I can see that I have the primary, the secondary, and the database is added to the availability group. And on the secondary side, I should have the database already synced and synchronized, right? So now let's add the resource in the cluster. I already have a cluster set up. Let's see its status. So it's a 2-nodes cluster. Both nodes are online, but no resources are yet configured. SQL Server Resource Agent for Pacemaker is included in the MS SQL Server HA package, which I already installed on both the nodes. So just to double check. Okay. I already have it installed. Now, all I have to do is to run the PCS resource create command to create the resource with the for the availability group that we just created. So using PCS resource create, we just gave the name, any name for the resource itself. We'll have to specify the type of the resource. Of course, the availability group name, we called it AG1, as well as a series of parameters that will tell the resource how many replicas we had created, how many can be online at once on a certain node, and also we're gonna tell the cluster that this is a master-slave type of resource, meaning to map the availability group primary, secondary. So I have 2 replicas. And using the same PCS status command, I should see now that the resource is created, and we can see that the master is on AGVM1 corresponding to the primary, and the secondary is on AGVM2. Now we can add a second resource to the cluster, which is the floating IP. This is a unique IP address that we'll use to connect to the primary. So we'll have to add constraints to the resource to collocate always with the primary. And this is going to be used for transparent reconnection after, in case of failover. So to create the floating IP resource, we use the same PCS resource create command. The same thing, we'll have to give it a name, specify the type of the resource, and the only required parameter is the actual IP that is going to be used. And as I was mentioning, we need to add a constraint to collocate the virtual IP resource and the master of AG cluster always on the same node. It looks like I misspelled something. Missing a C. Okay. And we can also add another constraint to make sure that upon failover, the virtual IP resource is not starting before the primary on the failover target node. So we can say, we can add another constraint, and we can say that the cluster will have to first promote the master of the AG cluster and then start the virtual IP. Okay, just double checking that everything is healthy, and you can see the virtual IP is added and is definitely collocated on the same node with the primary. Now let's try to perform a manual failover. For that, we're going to use the PCS resource move command. And we're going to say that the master will have to move to the other node. And using the PCS status, we can see that now virtual IP first stopped. We're seeing that the primary on AGVM1 was demoted, and we have 2 secondaries now. And soon we should see that the primary moved to AGVM2, and of course virtual IP started on the same node as well. Hope you found that useful. We are looking forward to your feedback on these capabilities. Thank you for watching.